Recently, I got myself these 775 DC motors, which you might have seen in different projects. With these 775 DC motors, you can make drill machines, you can make an electric bike, you can make a grinder, an RC toy car, RC boat, a solar fan, a water pump, a powerful table saw, and so on. In most applications, you will need a speed controller in order to control the speed of 775 DC motor. This video is sponsored by Altium. Altium Designer is the world's most trusted PCB design system. Altium Designer enables engineers to effortlessly connect with every facet of the electronics design process. Over 35 years of innovation and development focused on a truly unified design environment makes it the most widely used PCB design solution. With Altium Designer, you can create PCB designs with an intuitive and powerful interface that connects you to every aspect of the electronics design process. Route it your way through any angle, tune for delay, push, slide, and walk around faster than ever. Interact and collaborate with mechanical designers like never before in a photorealistic 3D design environment. If you want to get started with the Altium Designer, you can click on the first link in the description. So in this episode, we are going to be looking at different ways to control the 775 motor. I have these 4 different types of motor drivers. Each one has different voltage and current ratings. We will take a closer look at the technical specifications, pinout, connections, and practical demonstration. Throughout this video, I will use 3S11.1 volts Lipo battery, but you can use any DC power supply between 10 and 24 volts. Without any further delay, let's get started. The components and tools used in this video can be purchased from Amazon. The components purchase links are given in the description. This is the 775 DC motor with shaft diameter of approximately 5 mm and has the rated voltage of 24 volts and the maximum voltage is 36 volts. The rated speed of the 775 motor is from 3500 to 7000 RPM revolutions per minute. This RPM depends on the supplied voltage. A 12 volt DC current is 0.14 ampere and speed is 3500 RPM. 818 volt DC current is 0.15 ampere and speed is 4500 RPM. 824 volt DC current is 0.16 ampere and speed is 7000 RPM. Unlike other DC motors, the 775 motor has got these 2 wires, and when connected with desired voltage, the shaft starts spinning. The direction of rotation can be controlled by swapping the voltage wires. Now things get a little complicated when it comes to controlling the speed of 775 DC motor, because in market we have different types of low cost and expensive motor drivers offering low and high current ratings. I have got these different motor drivers and we will use each one with the 775 motor. These are not the only motor drivers. There are so many other types, but the ones you can see are the most commonly used motor drivers. This is a 3 ampere PWM DC 6 volt to 28 volt 1203B DC motor speed controller module. This DC motor speed controller allows controlling the speed of a DC motor using the pulse width modulated DC voltage with a duty cycle fully adjustable from 5% to 100%. This motor speed controller can easily provide a continuous current of 3 amps to your DC motor or other DC loads. The speed of the DC motor can be controlled using the onboard potentiometer. The module is also provided with terminal blocks which are used to connect the motor and power supply. On the bottom side, the terminals are clearly labeled as power minus, power plus, motor plus and motor minus. The input supply voltage of this motor driver is from 6 volt to 28 volt DC and has maximum output power of 80 watts. Connect the ground wire with the power minus contact and connect the positive voltage wire with the power plus, and connect the two wires of the 775 motor with the motor plus and motor minus contacts of the motor driver. Our connections are completed, and now we can start controlling the 775 DC motor using the potentiometer. The voltage applied to the motor will be supply voltage applied to the circuit. It is recommended to add an appropriately rated fuse in line with the positive supply in order to protect the circuit from any possible short circuits. This motor driver is the modified version of the 1203B motor driver. This motor driver can handle current up to 20 amps and accepts a wide range of input voltages from 10 to 60 volts DC. This motor driver also has got the same potentiometer and input and output contacts. On the bottom side, the contacts are clearly labeled as power plus, power minus, motor plus and motor minus. Connect the positive voltage wire with the power plus and connect the ground wire with the power minus, and connect the two wires of the 775 motor with the motor plus and motor minus contacts of the motor driver. Our connections are completed, and now we can start controlling the 775 DC motor using the potentiometer. The voltage applied to the motor will be supply voltage applied to the circuit. It is recommended to add an appropriately rated fuse in line with a positive supply in order to protect the circuit from any possible short circuits. This is a 320 ampere DC 7.2 volt to 16 volts brushed AC DC motor speed controller designed for e-bikes, RC cars, trucks and boats, etc. We have two types of ACs. These types of ACs are used to control brushless DC motors, while this one is used to control the speed and direction of brushed DC motors. So if you want to control your DC motor using a wireless transmitter and receiver, then you need to purchase this high ampere brushed AC DC motor speed controller. This motor driver is also provided with a button. The wires were removed when I received this module, but anyways I short the two wires and now this module will remain on until I remove the power supply. On the top you can see this light blue color aluminum heatsink and this small cooling fan. The yellow and blue color wires are the output wires and are connected with the DC motor. The red and black wires with the XT60 type connector are the input voltage wires. With the help of this, it can be easily connected with the Lipo batteries. These three wires are connected with the controller board like Arduino or a wireless receiver. The yellow wire is the signal wire. With this wire we send the PWM signal from our controller board to control the speed and direction of the 775 DC motor. The red wire is the 5 volt wire and it is used to power up the controller board or wireless receiver, and the brown wire is the ground wire. On this side you can see we have these two switches on the top and bottom side. These switches are used to program the motor driver. The button on the top side is used to select the operation mode. It's a 3-position switch and you can select any of these 3 modes: FBR, which is bidirectional mode, FB, which is the unidirectional mode, and FR, which is the climbing mode. The default value is bidirectional. If you want to know more about these modes, then read my article. I will provide a link in the description. For this video, I will continue with the default mode, that is FBR. The switch on the bottom side is a 2-position switch and is used to select the type of battery. The default position is set to the Lipo battery. Now let's go ahead and start the interfacing. I'm going to use the FlySky FSI6 receiver with the motor driver, and then we will use the FlySky transmitter to control the forward and reverse movement of the 775 motor. Connect the two wires of the 775 DC motor with the two output wires of the 320 ampere brushed ESC DC motor speed controller, and the polarity doesn't matter. Now connect the control signal wires with the receiver channel 3, which is the throttle channel. Make sure the signal wire, 5-volt wire and ground wire connects with the exact pins on the receiver. So that's all about the connections. Now we will connect the Lipo battery and then we are good to go. First we are going to control the 775 motor in the forward direction. To increase the speed, simply move the throttle stick in the forward direction, and to slowly stop the motor, move the stick in the downward direction. You can also apply brake if you quickly move the throttle stick in the reverse direction. When the throttle stick is in the middle position, the motor simply stops. So you can use the upper part of the throttle stick for the forward movement and speed control, and the lower part of the throttle stick is used to apply the brake and control the speed of the DC motor in the reverse direction. You cannot quickly change the direction of rotation of the DC motor. First you will have to stop the motor, and then you can slowly move the stick in the reverse direction. This will change the direction of the DC motor. You can also try the other two modes, the FB and FR. So if you are planning to wirelessly control your RC plane, car, boat, etc. using 775 DC motor or any other DC motor, then this is how you can do it. This is the L298N dual H-bridge motor driver. This motor driver can be used to control DC motors that have voltages between 5 and 35 volts with a peak current of up to 2 amps. As this is a dual H-bridge motor driver, it can be used to control the speed and direction of two DC motors at the same time. Now let's take a closer look at the pinout of the L298N motor driver. This module has 3 terminal blocks. This terminal block will be used for motor A and is clearly labeled with out 1 and out 2. This is where we connect the two wires of the DC motor. This terminal block will be used for motor B and is clearly labeled with out 3 and out 4, while this terminal block is labeled with 12 volt ground and plus 5 volt. The 12 volt terminal is used to supply the voltage to the DC motor. This voltage can be from 5 to 35 volts. The ground terminal is connected with the ground of the external power supply and is also connected with the ground of the controller board, which in my case is the Arduino board, which is based on the ATmega 328 microcontroller, while the plus 5 volt terminal will be connected with the Arduino's 5 volt. As you can see, this motor driver also have some male headers and are clearly labeled as ENA, N1, N2, N3, N4 and ENB. The ENA and ENB are used to enable both the motors. We can use jumper cables to enable both the motors, and the motors will rotate at their maximum speeds, or we can connect the ENA and ENB pins with the PWM pins of the Arduino, and this way we can control the speed of DC motors. The N1 and N2 pins are used for controlling the direction of motor A, while the N3 and N4 pins are used to control the direction of motor B. For the demonstration purposes, I'm going to control only one motor. Now let's take a look at the circuit diagram. The two wires of the 775 motor are connected with the out 1 and out 2. The positive and ground wires from the Lipo battery are connected with the 12 volt and ground contacts. 5 volt from the Arduino is connected with the 5 volt contact. Make sure the ground of the L298N motor driver is also connected with the ground of the Arduino. The ENA, N1 and N2 pins are connected with the Arduino pins 10, 9 and 8. The middle leg of the potentiometer is connected with the analog pin A1, while the other two legs of the potentiometer are connected with the 5V and ground. I connected everything as per the circuit diagram. My interfacing is completed, and now let's take a look at the programming. I started off by defining pins for the ENA, N1, N2 and potentiometer. I set the ENA, N1 and N2 pins as the output and potentiometer as the input. Inside the loop function, we are simply reading the potentiometer, then we map the value and then use the mapped value to control the speed of the 775 motor. N1 and N2, as you know, are used to control the direction. This high and low combination runs the 775 motor in forward direction, and if you change high into low and low into high, then the 775 motor will run in the reverse direction. So that's all about the programming. I have already uploaded this program. Let's watch the 775 DC motor and the L2918 motor driver in action. Support me on Patreon for more videos. I hope you liked today's episode. Like and share this video with your friends. See you in next episode, and thanks for watching.